linked list in data structure. Fine, so I'll provide you the link of that playlist in the description box as well as in this I button, and this playlist is containing all the videos of linked list. Fine, so now first of all, what is a circular linked list? See, this is what you can see a singly linked list. Fine, having 4 nodes, each node is having 2 parts, one is data part, one is address part, and this part, this pointer is containing address of the next node, that is address of next node is 150, right? Here 300, here 100, right? See, it's not compulsory that the addresses would be in ascending order or descending order. Any random address, any random location can be, dynamically allocated to these nodes, right? And we have a head pointer, head is containing address of the first node, right? Now, to make it a circular linked list, you just have to change it a little bit. And what is that change? See, in the last node, see, the pointer is containing 0, null. It means it is not pointing to any node. Now, to make it a circular list, what we will do, here we will store address of the first node. Now, address of the first node is 200. So, here we will write 200. It means this is now pointing to first node in the list. To make it a circle, and as you can see, this is now a circle. So, this is a circular linked list, right? In this list, we cannot say which is the last node, because see, this was the last node because it was having here null, but here we have the address of the first node, so it is a circle like this. In a circle, we cannot say from where the circle is going to start and where the circle is going to be end, right? So, now see how to implement this linked list, this circular linked list, how to create the linked list and how to display the content of this linked list, right? It is same as singly linked list, only one is this difference you have to implement, you have to change in that create function, right? So, now see how you will write that code. Same for this node, how to represent this node, same as we represent in singly linked list. So, this is how we are going to represent this node. Struct node, we have defined our own data type, 2 parts are there, data part and one is the next, or you can say this pointer is next pointer, which is containing address of the next node, and I have declared one pointer also, that is head pointer. See, this pointer is containing address of this node, right? If you don't write this like this, you can write here semicolon, or here you can write struct node, this data type asterisk head pointer, right? And I hope everybody is aware about this thing, why I am writing here struct node asterisk next. I have discussed it many times in the previous videos, right? Because here, see, suppose if you write asterisk p, it means this is pointer to int. This pointer is containing address of a variable, and the data type of that variable is integer. So, here we will write what? The address of that variable whose address this pointer is going to store. So, that is why here this next pointer, this is going to store this address, and this address is of this node. So, data type of this node is struct node, we have already defined. So, that is why here I am writing the data type of that node, that is struct node. Fine. Now we will define a function how to create this linked list, that is create a circular linked list. Fine. It is same as singly linked list. I have discussed the code for singly linked list in the previous video. I'll provide the link of that video in the side button, you can check out there. First of all, we consider what? The list is empty, we don't have any node in the list. So, you can say head is what? 0, head is equal to null. So, here I can write head is equal to 0. Now, to insert these nodes, first of all, you have to create these nodes. You have to dynamically allocate the memory to these nodes, right? Obviously, we are going to allocate the memory for storing this integer type data and this pointer variable. Fine. So, how we allocate the memory? Dynamically, we are going to allocate the memory using malloc function in C, and I hope you know the syntax of malloc function. We have already discussed many times. How we will write? Here we will basically write what? That malloc keyword, and in bracket we write size of a keyword. How much size you want? Size for this node. So, here you will write the data type of this node, that is struct node, right? And malloc is going to return what? The starting address, pointer to the starting address of that allocated block, right? See, suppose initially we don't have anything in the list. like this, head is containing 0, and if you write this malloc means memory has been allocated. How much memory for this struct node? 4 bytes for this and 4 bytes for this. 4 bytes for this pointer in 32-bit compiler and 8 bytes in 64-bit compiler. So now 8 bytes has been allocated. This is the block of 8 bytes, and suppose the address of this is, the address of starting byte is 200, right? So this block has been allocated. Now malloc will return what? The pointer to this node. You can say the address, the pointer to the starting address of this node, that is malloc will return what? This 200. So we are going to store this 200, fine. So we are going to create another pointer, we are going to declare another pointer, you can say new node, and in new node we are going to store this address. But malloc basically returns what? A void pointer, and this pointer is what? It is a pointer to node. So you have to typecast this one, whatever this malloc will return. And how you will typecast this thing? Here you will write struct node asterisk, and now we can store this value in this pointer, new node pointer. So here I can say, now here I have a new node pointer and this is containing 200, means this is pointing to this node. Fine. Now we will ask from the user which data I want to insert using printf and scanf. So this is how we can take input from the user using printf and scanf. %d address of where I want to store that value. Suppose here 7 I want to store, user has entered 7. So how we can access this part? The name of this part is data. We cannot directly access the structure members. We need a pointer. Pointer to this node is what? New node. So address of new node arrow data. This part I want to access. So here the value is to be stored. Fine. Now initially we store here the pointer. In the pointer we store what? Null. So I can say how you can access this part. The pointer is new node arrow and this name is next is equal to 0. Now I want to insert this node into the list. How you will insert? Because list is empty. So now directly what you can do? In head we will store what? This 200. It means now head is pointing to this node. Now this is a list, right? So directly I can write here what? Head is equal to new node. Fine. But this is not done. That is fine if you insert first one node. Now if I want to insert a second node, in that case suppose this is a node. So now see this, now the new node would be pointing to this node. Suppose address is 150. So now new node is going to store 150. New node is pointing to this node, right? And if I write here head is equal to new node, means head is going to contain now 150. So head, this link would be broken and head will point to this node. So we are going to lose a reference to this node, and that we don't want, right? Because obviously we want to insert second node. Fine. So you cannot directly write this thing. What we can write? One condition, if head is equal to null, means if head is equal to 0 at starting, if there is no node in the list, that in that case head is equal to new node, that is fine. Else what we can do? Now else means I am going to create, I have created this second node, I have created this node, new node, I have stored 150, and now I want to insert this node here. So now what you have to do? Obviously here you will update what? Here I will store 150. After that only it is going to point here. Now how I can access this part? See, pointer to this node is head. Head next. So I can write here, suppose head next is equal to new node. But now this is also not correct, right? Now this is fine, we have inserted 150 here and now this is pointing to here. Now if I want to insert a third node, in that case what happens? Now if head is equal to null but head is containing 200, so this condition is not true, so control will go into else part. In else what I have written, head of next, means head of next, this part. This part, in this part we are going to store new node, means new node, after creating this node, new node would contain 300, right? So now new node would point to this node. So now head next, here I am going to store 300. It means you will lose this link and this node will directly link to this node. So using this logic also you can insert only 2 nodes. So this is not a correct logic. Now here what I will do, see, you have to take another pointer, that is temp, because we cannot move head for accessing. In this case, after inserting 2 nodes, I want to insert this one, so I'll put here, rather than 0, I want to store here 300, so that I can establish a link to this node. But how I can access this part of this node, because we don't have any pointer pointing to this node. Head is pointing to the first node, new node is pointing to the newly created node. So how we can access this node? So we need to maintain another pointer, you can say temp. So here you can have another pointer, that is temp, right? And if head is equal to null, head is equal to new node, or here only we will store temp also containing whatever the value in new node. So after inserting this first node, we have another pointer that is also having this 200. So this is also pointing to this node. Now I can move this temp. How I can do this? See, now in else part, what I will write? See, suppose I have inserted this one and I want to insert this second node, not third node, I want to insert second node. Now, how I can access this part? Using temp. We will use temp now because we cannot move this head. So temp next. So here I will write what? Temp of next is equal to, here I want to store address of this node 150. From here I can get 150. In new node pointer we have 150, right? And now here I have 150. So now this, there is a link between this and this, as well as we will do what? In temp now we are going to store whatever the value in new node, fine. So now in temp also we are having 150. So now temp is pointing to this node. Now see, if you want to insert this third node, in that case, if part is not true, so we are going in else part, we are going to enter into else part. In else part, what we will do? Temp next. Using temp, which node I can access? This node. Temp next means here I will insert new node. So after creating this node, now in new node I have address of this node, right? That is 300. So now here I will store 300 and temp is equal to new node. So temp is containing whatever the value in new node, that is now 300. So now temp is pointing to this node. And if you want to insert fourth node, that is also fine. In else part, temp next. Temp of next means this one. Here I will store whatever the value in new node, in newly created node, fine. And after that we will move this temp, right? Now suppose I want to stop here. I don't want to insert any extra node. Now one more thing you have to do to make it a circular list. Here you will store what? This address of this node, fine. So after this else part, what you will write? See, how we can access this part? The pointer to this node is, you can say temp. Temp of next is equal to, I want to store here this 200. From where I can get this address? In head we have 200. So here I can write head. So now it is having 200, fine. And now this pointer, this node is pointing to this one. And now this is a circular linked list. See, as you can see. So only this line you have to add in this code of single linked list creation to make it a circular linked list. And now you can write the same code. You can write here printf. You will ask from the user, do you want to continue, want to insert another node? Type 1 for continuation and 0 for exit. And here you can write scanf %d and address of one variable you can take, that is choice. And you can take here in this function only, you can declare, after this function you can initialize a variable choice is equal to 1, right? And if choice means if user press 1, it means a new node would be created. Another, if again user press 1, another new node would be created. It means these lines from this line, because this is the line where dynamically this memory would be allocated, means new node would be created. So these lines would be in loop. So here I can write, before this line I can write while choice and in the bracket. Fine. So here you can write, after this else printf, 1, press 1 for continuation and 0 for exit. So here scanf you can write %d address of choice, and after that you can close the while loop and you can close this function create CLL, right? This is how you can create a circular linked list. This is not the only way to create a circular linked list. Sometimes somewhere you find out that they will maintain the last node, not the head node. That is also fine. You can maintain a last node, means the tail node, pointed to the tail node, not the head node. And see, if you want to cross check that we have created a circular linked list or not, then what you can do, here after this printf and scanf, after maybe this while loop, you can do what? You can print what? See, here this is the last node, and after inserting 3, temp would be pointing to the last node, right? Now temp is pointing to this node. So in printf, what you can print? Temp next. Temp next means this thing, right? 200. So 200 means we have reached till this node, and the data of this node is 7. So again arrow and data. So this should be printed what? 7, right? It means we have created a circular linked list. So now we will see how to display this circular linked list. So now for traversing this list from here to here, or you can say for displaying the data, obviously we need a pointer because we cannot move this head, we need another pointer, right? So now this is the function, we are going to define this function, and here I want to take another pointer, that is temp. Using temp we are going to traverse, right? Here suppose I have temp. First of all, what we will do, if we will check if head is equal to null, it means there is no node in the list. So here you can write what? Printf list is empty, right? Else, in else part, what you will write? Now see, first of all we will point this temp to this node, that is we are going to store 200 in this temp. Now from where I can get this 200? In head we have 200. So here I'll write what? Temp is equal to head. So now how you can print this data? See, this pointer is, this node is having a pointer temp and head also, but we will use temp because we are going to move this temp. Temp of data. So how you can print? Suppose it printf, I can write what? %d and temp data. This is how you can access this part of this node, temp, and the name of this part is arrow data part. Fine. So now this will print what? 7. But now we want to print 6 also, then 1 also. So now we have to use a loop, and from where till where I want to print? Till here. So now in single linked list what we have done? While temp not equal to null, because in that case here null, it was the last pointer, but here this is not a case, here we don't have null. So what condition you will write in while loop? So before this line, before printing, what you will write? You will write a while loop, while. Now the condition is what? See, I can write what? I can write a condition on this part. Here we have 200, and 200 is what? Address of this first node. It means we have reached to the last node. If I write here 200, fine. So you need to write something like this. So suppose at some time temp reached to here. So I can write temp next not equal to head, because head is containing this address, not equal to head. Till then we are going to print this, and after printing we will do what? We will move this temp. Temp is equal to temp of next. Now here also one problem is there. See, what is that problem? At starting, while temp is equal to head means 200, while temp next not equal to head, temp of next is 150, and in head we have 200. So this condition is true. Fine. So we will enter into this loop and we will print temp of data. Temp of data means 7 would be printed, right? Now temp is equal to temp next. In temp we have temp next. Temp next we have, in temp next we have 150. So here we are going to store now 150. So now temp is pointing to this node 150. Again while loop, temp next. What is temp next? That is 300. 300 not equal to head. Yes, condition is true. Again we will enter into this loop. we will print temp data. Temp data means 6 would be printed. Again temp would be moved. Temp next is having 300. So now temp is having 300. So now temp is pointing to this node. Now again while loop, temp next not equal to head. Now what is temp of next? Temp is pointing to this node and next part is this one, that is 200. But 200 not equal to 200. So this condition is not true now. Fine. So we cannot enter into this loop because in temp next we have 200. So now we are going to do what? We are going to exit from this loop, right? But now we have printed only 7 and 6, 1 I want to print, right? And using this I cannot print this thing. So after this you will write one more line, that is printf %d. How you can print this one? Because temp is pointing to this node after this while loop. So here I can write temp of data. Temp data means 1 would be printed here, right? So after this while loop you will add one more line to display all the content of this list. So this is how we are going to display. You are going to traverse, you can say, the circular linked list. Only one difference is there. Only one difference this was, and second one is in the while loop we are going to change the condition. We cannot write down that condition of null because we don't have null in the circular linked list. Fine. Somewhere you will find out that they will maintain only the last node, and using the last node they will traverse the list. So that also we will discuss later in the videos. So this is all about how to traverse a circular linked list and how to create a circular linked list. So in next video we will see how to insert data in a circular linked list. So I'll see you in the next video. Till then, bye bye, take care.